Okay, ladies and gentlemen, we're going to start dealing with Pre-Calculus Chapter 9. We're going to be dealing with polar coordinates. Now, polar coordinates are a little bit different than you're used to. Previously, everything worked on an XY axis. You always had X comma Y, and all you had to do was go over a certain amount and up or down a certain amount. So over X, up Y. Everything was in terms of that. Now, in vectors, we did get a little bit into superimposing 4 comma 30 degrees. Something like this on an XY plane. So we said, well, we're going to go out 4 units. 1, 2, 3, 4 units. And then we're going to rotate that vector up 30 degrees. What in essence you're really doing is polar coordinates. And they're named polar coordinates because they all center around one pole, right there. And from that one pole, everything radiates out in each of its various directions. Now, in polar coordinates, you have r comma theta. Now, that should look very familiar. Our vectors were magnitude comma theta. In this case, it's going to be r comma theta. Everything is in terms of circles, so r stands for radius. So we have radius comma theta. If I'm going to graph a few of these guys on this graph, let's come up with 2 comma 30, 5 comma negative 45, and 10 comma 201. Somewhere in that ballpark. So if I have 2 comma 30, I go out 2 rings up 30 degrees. Now, if this is still 0, and that is still 90, and that is still 180, and that is still 270, now what we have is we have a halfway point that would make 45. So I have 30, 45, 60, on around as we're used to. So 230 would be 2 rings out at 30 degrees. Now you'll notice there's no arrow on that, it's just a point. If I said 5, negative 45, I'm going to go out 1, 2, 3, 4, 5 rings, and I'm going to go 45 out. It's just a point. Probably ought to be putting some labels on here. 10 comma 201, so I go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 201 would be somewhere over in this ballpark. Now, these are simply points, but they each have a radius and they have an angle. Okay, now, that's one way, is to go out the certain number of radius, then around to the correct angle. I kind of prefer to go in the opposite way. I prefer to do all of the angles first. So I figure, okay, 130 is going to be just shy of 135, so it's going to be somewhere in this ballpark. And I'm going to go out 6 rings on that line. 1, 2, 3, 4, 5, 6. There it is. So I figure out the angle first, then I put the dimension on it. 7 comma 90. Well, I know 90 is right here, so I simply go 1, 2, 3, 4, 5, 6, 7, 7. So I have 7 comma 90. Now, we can go negative angles. Showed you that. You simply go backwards rather than the standard from the positive, what used to be the positive x-axis. You'll notice there is no x-axis, no y-axis on that. If I were to superimpose an x-axis and a y-axis on that, that could be fairly useful because, for example, if I have something out 1, 2, 3, 4, 5, 6, 7, 8 units, 8 comma 30 degrees. Well, if I were to create a triangle with that, I could find the radius, which is 8. That would mean, because of 30, 60, 90 triangles, that this side over here happens to be 4, and this side over here happens to be 4 root 3. So now I start to get the idea that if I have 8 comma 30 degrees in polar form, I should be able to convert it over to rectangular form. Now, rectangular form, I simply find the x component and the y component. In this case, 4 comma 4 root 3 would get me to the same spot. Now, the way to do that is not shockingly using a couple formulas we already know. We already know that x equals r cosine theta and y equals r sine theta. And it's going to work out exactly the same way, because our x is going to be 8 cosine 30, and cosine of 30 is 1 root 3 over, it's going to be root 3 over 2. And if I have y equals 8 sine 30, sine 30 is 1/2. 1/2 is this. Very quickly, I've put these backwards. I found the 4 first. I found the 4 root 3 second. You'll notice I put the 4 in the x spot. That is not correct, because if this is 30 degrees, this adjacent side is going to be longer, the opposite side is going to be shorter. So I apologize. It is 4 root 3 comma 4. That's your rectangular form, but it's using the same formulas that we're already familiar with. So converting from polar to rectangular, not a challenge. One thing that might be a little bit different is if I give you a point like this. If I say negative 6 comma 45. Now, if it were negative 45, we would simply go down 45. Since the radius is negative 6, instead of going 6 out